And after the class, do practice them, because until and unless you will not practice, you won't get anything. Okay?
Okay. Teacher, should I write this?
No.
Okay.
So let's just start. Okay. So your first theorem is, first of all, what in this entire chapter you should remember three things. No matter whether you are getting the things or not. Like for example, the question came and you are not aware, right? You will draw the diagram, right? You will write given, you will write to prove, and then you will write the proof. Okay. These are the things which you need to do. Okay. So let's just start with theorem 6.1. Okay, the first theorem is, if a line is drawn parallel to one side of the triangle to intersect the other two sides in distant point, the other two sides are divided in the same ratio. So first of all, what they are saying, you have a triangle, right? If a line is drawn parallel, so this is your third side, right? So what you did, you made a line parallel to your third side, right? And these are the points, D and E, right? So these are the points. So this is what you draw the diagram, okay? Then you have to write what is given to you. So a triangle is given to you. Then ma'am, this is a triangle ABC, right? And over here, DE is parallel to your BC, right? This is given, okay? Very, very important. No matter what, you have to write given, you have to write to prove, right? And okay, given is done. Now, like ma'am, what we have to prove? You have to prove this. The other, you have to prove the other two sides are divided in the same ratio. That means this AD is equal AD, this and DB. This AD is equals to your AE, okay? And this BD is equals to your EC. They are divided into same ratio. So ratio means like this. For example, it's 2 divided by 3. So ratio means 2, 3. Like this. These are the points. These 2 points represent ratio. Right? So this is what? To prove, you know that ma'am, okay, AD, you are AD and DB. You are dividing it. They are equals to AE and EC. Clear? Robin.
Yes, teacher.
Okay. Now, see, of course, you have to do some construction. It's not easy for you to, just do it. So, a construction. What you will construct, first of all, see, what you will do, join BE. Taking from here, you will make a line and you will join it. BE, join BE and CD. BE you will join by dotted lines and CED you will join by dotted lines. Okay. And then what you have to do, you have to draw perpendicular. This sign is basically for perpendicular. So, you will draw DM perpendicular. So, ma'am, what is the difference between these lines and these lines? See, over here, whenever you draw perpendicular, you draw this angle, which is your 90 degree. So, over here, if you are drawing DM, you have shown the line, you have shown the angle that this is perpendicular. Perpendicular means 90 degree, right? So, DM and ME. This is what you did the construction. Clear? So, what construction you did? First of all, you joined BE and this, right? And similarly, over here, what you did? CM is perpendicular. DM and over here EN. Okay. Yeah. NE or EN, same thing. Okay. Okay. Now you have this entire thing, right? You have the entire diagram like this. Earlier it was very simple. It was like this. Then you made it like this. Now you have this diagram. Okay. So what we have to prove, basically we have to prove AD divided by DB is equals to AE divided by EC, right? So let's just take this. Area of triangle ADE. ADE. You are taking this triangle. Okay. Over here, half into base into height. This is the area of a triangle. Yes. Yes or no?
Yes.
Right? This is the formula. Whenever you have to find the area for a triangle, this is the formula. Half
B
into h, base into height. So this is your triangle. So what is your base? This is your base, AD,
Yes.
right?
AD.
Most of the time, what students do, they think this is the base, DE.
DE. Yes.
No, why this is not a base? Can you please tell me?
That is because in this triangle, uh,
Mm-hmm.
one-
See, I'll tell you. See, for example, if over here you have drawn this perpendiculars, right? For
yeah,
example, if perpendiculars are not there, so of course you can take DE as base, not a problem. But over here you can see perpendicular are falling on this line. So perpendicular always fall on base,
the base.
right? So that's why this EN is falling in AD. That's why you took AD as a base. Okay. And what will be the height? This. This will be the height. The perpendicular will be the height itself. Clear?
Yes.
So you took like this, that in triangle ADE, this half, this. This is the first situation. Okay. Then which triangle you will take? You will take this triangle, BDE, this one. Okay.
Mm,
Over here, what you will take? DB, this one. This is your base. Okay.
yes.
And what is your height? This. EN is your height.
Mm,
This one.
okay.
Getting the point? Now you will be working,
Yes.
ma'am. This is the triangle, but how come I will be taking this height? You
Mm,
thinking this? Right?
yes.
But over
Yes.
here, see what I told you, bases always have a height which are perpendicular, right? So always
Yes.
remember, if you are taking this triangle BDE, this triangle you are taking, right?
Yes.
So this height, this can become here, right? Because over here you have only one perpendicular. In this entire line, you will have one perpendicular. You will have only one perpendicular, which is your EN, right? So no matter whether you take this triangle, this triangle, this triangle, this side, whenever you are taking any triangle from this side, this EN will be your height, because if for example this EN is not here, at that time you can take DE as a base or BD, anything. But over here, why you took this base? Because in this entire line,
Perpendicular.
perpendicular is falling, and similarly over here you have no perpendicular, so you will take this as a height, EN as a height, because in this entire line, EN is the only perpendicular. Clear?
Yes.
Right? Okay, so we are done with this part. Okay, now we will move to this part. Okay, so first of all, again you will take this triangle, right? Now you
Mm,
are not going to take this side, you are going to take this side. So now you can easily do it. Half into base into height. So now what will be the base here? This
AE.
AE? Yes. And
Yes.
what will be the height?
DM.
Yes. And
or
coming
MD.
to this triangle, now you will take this triangle.
Mm,
Okay, earlier you took this triangle, now you will take this triangle. So now I think you can do it, right?
yes.
Half into base into height. So
The
what will
height.
be your base? EC will be your
Uh,
base.
yes.
And what will be your height?
MD.
Yes, very good. So this is your height. So now you have first equation, second equation, third equation, and fourth equation. Done. Right?
Yes.
Now what you will do, you will divide first and second. These two you will divide. And third and fourth you will divide. Okay? So how come you will be dividing? Area of this, right? ADE
Mm,
divided by area of BDE. So what is the area? Half into AD multiplied by AN. This is the, and this is the. So now you are going to, what you are going to divide it. So you can see EN and EN will be cancelled out.
cancel.
Half and half
Half
will be
and half
cancelled. What will
cancel.
remain? AD and DB. Similarly here you will divide these two. Half and half will
Half
be
of
gone out. DM, DM,
DM.
this. So now
A.
this is your equation A, right? And this is
Mm,
equation B.
B.
Yeah. So similarly now triangle BDE and DEC are on the same base. Over here you can see they are, whether you are taking this triangle and this triangle, they are on the same base,
Yes.
right? So, and between the same parallel, okay? Same base and between the same parallel, right? Therefore, the area of BDE, this one is equals to area of DEC,
DEC.
right? So these two areas are equal. Why these two are equal? Because they are on the same base.
Same
Plus, this
and
is the parallel line. This is the parallel line between the two parallels,
B.
same
Yes.
parallels, right? These two
Yes.
triangles, right? So of course, if they are, for example, you and I, we both are in 10th class. So of course, our areas, our subject will be same,
Yes.
right? So similarly, these two triangles have same base, plus they are between the same parallel. That's why their areas are same, right? So you wrote area of BDE, this triangle, is equals to area of this triangle. Okay. So now what is here? Area of ADE, this one, ADE. Okay. This triangle
Mhm.
is divided by area of triangle BDE. This triangle, because over here this is what, this was the situation, right? This situation
Yes.
and this situation. So what you did, area of this equals to area of this, right? From here, now what you can do, AD is equals to DB. What was remaining? AD, DB, and this
By EC.
AC. So hence proved. Clear?
Yes.
Yes. So over here, now the question is, they can ask you like why these areas are equal. So this is what, or what you can do over here, you wrote this, right? But
Mm.
now see, you right now over here you got AD divided by DB and AE divided by EC. But right now you have no clue that these are equal, right? That's why you wrote this line, that this triangle area is equal to this triangle area, right? That's why you can write it like this. Okay.
Yes.
Okay, so most of the time what students do, they have just drawn this, and after this they will write this is equals to this. But how? You have to give reason, right? How
Yes.
come, see, these are equals to this, but how come these are equals to one another? They are two different parts. You have drawn a line here. These are
Yes.
different. So ma'am, because of this reason, because these two triangles lies in on same base and between the
Parallel.
same parallel,
Same
that's
parallel.
why their areas are equal, and we can write it like this, that ma'am, BD is equals to DEC, and AD is always AD, right? Over here, AD is equals to this, right? So AD is area, because AD you are taking two times, right? One when
Mm.
you are taking this base and this perpendicular, and one when you are taking this base and this perpendicular. So area of AD is equals to area AD, yes, but these two, how come they are equal? Because of this reason. So yes, these are equal from A and B, hence proof. Clear?
Yes.
Okay. So you'll quickly write it down.
Okay.
Wait a minute. So you don't need to draw diagram again and again. Okay, you will just draw one diagram. Okay.
Okay.
This was for
Okay.
the explanation. That's why I wrote it again. But follow the system, okay?
Okay.
The systematic manner. Wait. So instead of writing theorem, what you can write theorem 6.1 instead of writing the entire theorem. Okay. After that,
Okay.
after the class, you can write it if you want. You can leave one or two lines for that. Okay, because
Okay.
you have your NCRT book with you, right?
Yes.
So you can write it from there. So first of all, what you will write, theorem 6.1, and after this, you will draw this. This diagram is important. Okay, and after that, given, prove, and construction.
Okay.
And over here, to prove what you have to prove AD upon D. To prove here and prove you are starting. Okay.
Okay.
This theorem is also known as some other name. Okay. So what they can do, they can even ask you, you can write it down. This theorem is known as BPT. Okay. So ma'am, what is this base BPT? This is basically basic
Basic proportionality
proportionality.
theorem.
Yes. Good. So they can even ask you, prove BPT. Right. So
Yeah.
like this. After that, we will do inverse. Inverse means it will be opposite.
Yes, teacher, I finished this. Yes, teacher, finished. Yes, teacher, finished.
Okay. Now theorem 10.2. Oh, sorry, 6.2. Okay. So it is reverse. Now what is happening over here? If lines are divided any two sides of the triangle in the same ratio, then the lines are parallel to the third side. Over here, what it was? They have already given you that lines are parallel. You have to prove that they are equal to the third side. Right? They are dividing into same part. Right? But
Yes.
over here, they are asking you to prove that the line is parallel to the third side. They have given you. It's reverse to your previous
First.
theorem. Yes. So, see, given triangle is given plus DE is a line intersecting this and this, right? And over here, remember, you have to do this. Okay, this E dash. Then this line is basically drawn in such a way that your AD divided by DB and AE divided by EC, okay, is equal, right? Because this is given already. This one is given. Earlier, we had to prove this one, right? What you have to prove now, you have to prove that this DE is parallel to your this BC. Okay. So over here, what you will write given triangle ABC and then you will write this. Okay. You will not write DE and everything. Okay. Then construction, what you will do, you will draw D and E dash. Okay. And this DE dash is parallel to your BC. Clear?
Yes.
Okay. So since your DE dash is parallel to BC, okay, according to, see, these are parallel, right? So
Yes.
in the according to the previous theorem, if the line drawn parallel to one side of the triangle to intersecting other two sides, no distant point, the other two sides are dividing them in the same ratio, right? So now earlier
Yes.
over here, what is given? DE is parallel to BC, but now you made this point. Now your DE
E
dash is parallel. So that means AD divided by DB
AD by
A.
is equal to AE dash divided by E dash by
Yes.
C. E
Yes.
dash C.
Yes. Very good. So this is right. So this is your first equation. Now it is given, this one is already given, right? AD is and this, right? So
Yes.
from first and second, what you are getting, you will add 1 on both the side. Okay. Over here, you can see AD divided by DB is equals to this and this is equal. So that means these two are equal, right? This
Yes.
AE dash, right? Are you getting this? See,
Yes.
this is equal to this and this is equal to this. That means these two are equal. So yes, ma'am, these two are equal. Now what you will do, now you have this. Now you will add a 1 on both the sides. So when you are going to add 1, so over here what you will do, you will take the LCM, right? So now it is A E dash divided by E dash C plus
C.
1. So what you will do, 1 will be your LCM and this will be 1 multiplied by A E dash, right? Plus over here it's
Mm.
1, right? So 1 is like 1 multiplied by A.
One
Yes,
E
1
dash
multiplied by
C.
huh. Okay, so this is what you got. Okay, this means 1. Over here it was
Yes.
1. To make it E dash C, what you have to do, you have to multiply E dash C with 1, right? So 1 multiplied by,
Yes.
you know how to calculate this LCM? Yes.
Yes. Yes.
Okay, so in case if you are not getting it, I'll just explain you in depth. Okay, you want me to explain it?
No, no, teacher, I know that.
Okay, so because of this, you got these two equations, right?
Yes.
Now you have this, you will solve this now. Over here, it is E dash C and this. So what you did,
Mm.
when you will add E dash E plus this, what you will get? You will get AC, right?
Yes.
This plus this. What you will get? This AC, right?
Yes.
Right?
Yes.
So you got AC and over here AE and EC. AE. Adding this and this. Again, you will get AC,
AC.
right?
AC.
The next part, these will remain same. So now over here, when you will solve, you can just deduct it 1 and 1. Yes.
Yes.
So now what is happening over here? This is equal to this. What they did over here, they cross multiplied it, right? So your
Yes.
AC came here AC and your E dash C is equals to EC. So when you derive, it's 1. Now these two, again over it's 1. So you will go here. Now EC is equals to E dash C. Clear?
Yes.
So what is happening over here? E again is coming in both, right? C is
Yes.
coming in both. So thus E and E dash are coincide. They are somewhere coinciding, right? So as you know that
Teacher,
DE dash is parallel to BC. Sorry.
what is coincide?
Coincide means, see, when you are taking coincide means they are again coming again and again, right?
Oh,
Yeah,
yes.
so there is coincide. Okay, getting
Thank
the
you.
point? Yeah.
Yes.
Or maybe somewhere like they are coincide means, for example, this is a triangle, this is a triangle, right? So somewhere they are same, right? So they are somewhere
Yes.
same. So you can see whether you are taking A, E, and EC, it's coming same. Whether you are taking A, E dash, and E dash C, it's also coming AC. So somewhere these two have some similar properties. This E dash, AE dash, and AE, they have similar property, yes?
Yes.
Right? Because when you added AE dash
AC.
plus AE,
Mm,
A dash C, then also you got
mm,
AC.
but
When you
AC.
are adding these two, then also you are getting, so that means E and E dash
AC.
are coincide, somewhere same, right? So since
Yes.
you know that your DE dash is parallel to BC, so this means your DE is parallel to BC.
BC.
Why? Because you already know that these two are same. So of course, whether to take E dash or E, both are the same thing, right? So you
Yes.
already know that DE dash is parallel to DC, right? So over
Yes.
here, what you said, they are coincide, they are same. So if you will take DE, then also it's the same thing because these two are same,
Same.
right? So this
Yes.
is what it's hence proved. This is what you have to prove, that DE is parallel to this. So yes, ma'am, it's proved whether you take DE dash or DE, both are the same. Clear?
Yes.
Okay, so you will write it down.
Okay.
Let me just erase it. So over here, instead of writing theorem 6, just write by theorem 6.1. Okay, just don't write again.
Mm, okay.
Okay, yeah, you don't have, just write theorem 6.2 and reverse of your previous one. Okay, and then given, over here given, you have to write triangle ABC. Okay, and
Okay.
then this
Mm,
AD.
okay.
Yeah.
Yes, teacher finished. Yes, teacher, done. Yes, teacher, done.
Now let's just do the third one. Okay, the third one is basically over here you are proving your AAA criteria, which is angle, angle, angle. Okay, so it is like if two triangles corresponding angles are equal. So you have two triangles, but their corresponding angles are equal. Okay, then their corresponding sides are in the same ratio or proportion, and hence the two triangles similar. Okay, so what they are saying, they have just given you these are the two triangles, this and this. Okay, so they have corresponding angles equal. Okay, the angle A to angle D, right? Angle B to angle E, angle C to angle F. So these are equal, right? So all the three sides corresponding means on the, for example, it's the upper one. So here it will be the upper one, not the lower one. Okay, so they are equal. And what you have to prove, see this sign. This is the sign of similarity, right? So you have to prove that this triangle is equals to similar to this triangle. Okay, equally they are saying similar. Okay, when they
Okay.
give you a sign like this, similar and equal, this is they are congruent. Okay, so let's just do the construction part. So over here you can see this is a small triangle, this is a bigger one, right? So you will draw a triangle. Now if you will ignore this, now you can see they are of same size. Yes,
Yes.
yes. So what you did, the construction is you draw this PQ, okay, such that DP is equals to your AB, okay, and DQ is equals to your AC, and BC is equals to PQ in such a way. Getting the point?
Yes.
Okay, so these, why I draw this, because one was small and one was big. So of course you cannot say that these are similar. By looking itself, you can say they are
Yes.
not similar. But
Not
so we
similar.
have to make it somewhere similar. So I made this construction. Now over here you have to prove. Let's just start. So this triangle and this triangle. In triangle ABC and triangle DPQ. Okay, you know this AD is equals to DP. AD this sorry, AB is equals to DP. Why? Because when you were constructing, you said this. Yes,
Yes.
and then A is equals to this, it's already given, right? This is
Yes.
equals to this, and
Yes.
AC is equals to DQ. AC is equals to DQ. This also, when you were
Make.
constructing, you said,
Yes.
ma'am, they are equal. So that means this is what you can see, this sign, two signs, and this, right? So this is
Congruent.
congruent. So this triangle is congruent to this by which property? By SAS.
SCA.
You have
Side
two
angle
sides and
side.
one angle. Yes. So
Yes.
over here you can see that angle B is equals to angle P. Why?
Teacher,
By
I have
CP
one
side.
doubt.
Yes.
So in SAS criterion,
Hmm.
it's only SAS if the angle is included in between the two sides, or if it's like not
No, no, no.
included.
It's not like, for example, you wrote these two here, two sides. Then you don't have to look it like this. You will not write SA, SSA, though.
Okay.
Okay, you will only write SAS. Okay, no matter whether you are writing angle in the third number or the fourth number or the very first. Okay.
No, my doubt was like here we proved that AB is equal to DP
Mhm.
and AC is equal to DQ.
Yes.
So if we weren't taking, for example, if we were not taking angle A is equal to angle D, we just took in a question we took angle B is equal to angle P. So we cannot prove it by AS, right?
Yes, yes, yes. No, 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 no. That in that case also it will be side angle and side SAS
But
only.
the angle should be included between the two sides, right?
No, no, nothing like that. You just have to see. See, you have only three criteria somewhere, right? SAS, AA, and SAS, right? So
Yes.
no matter whether the angle are in between or not in between, you will only check whether it's an angle or a side. That's it.
Okay.
The
Okay,
situation, the
teacher.
position doesn't matter. Only check whether it's a side or angle. Okay,
Okay,
and
teacher.
accordingly you'll apply the formula. No matter it's wherever it is. Okay.
Okay, teacher.
Yeah. So over here now by CPCT, you can write that angle B is equals to angle P, right?
Yes.
Because now these two triangles are congruent. So every side, every angle will be equal because you already proved that they are congruent, right? So now
Yes.
angle B is equals to angle P, right? And similarly, angle, you know that angle B is equals to angle E, right?
Yes.
And you also know that angle B is equals to angle P, right? So can you
Yes.
write this? That angle
Yes.
P is equals to angle E?
Yes.
Yes, right? So for lines PQ and EF, PQ and EF, right? Angle P and angle P are corresponding angles, right? They are somewhere same and they have
Yes.
equal and they are equal. So you have, you know this, they are corresponding, same, right? As
Yes.
well as they are equal. So you can write
Mm.
that PQ is parallel to EF. Clear?
Yes.
Yeah. So now PQ is parallel to EF, these two things. Okay, by theorem 6.1, you know that if these are equal, then they will be dividing into same proportion. So it will be DP divided by PE and DQ
P.
divided by QF,
QF.
right? So similarly, this
Mm.
came, and similarly you can write it PE, right? So over here, PE
Yes.
divided by DP and QF, like I reversed it, right?
Yes.
So what I will do, I will add them,
Add
right?
one.
Similarly, so you will get this, right?
Yes.
And what you got this, you know, by add by the construction dp is equals to ab and dq is equals to ac, right? This dp is equals to ab.
Yes.
So instead of dp, what you can write, you can write ab, and in place of dq you can write ac.
AC.
Clear? So similarly we can prove this equals to this, therefore all the thing ab, this ab is equals to ac, right?
AC.
And bc.
Yes.
Okay, and DE is
Mm.
equals to this. So all the three sides are in proportion, right? So therefore you can see these two triangles are basically similar to,
Similar.
this triangle is similar to this triangle. Clear?
Yes.
Okay. Wait a minute. Let me just erase it, okay?
Okay.
Uh, uh, yeah, you can write it down.
DJ, what should I write the heading? Theorem?
Yeah, just write theorem 6.3 and in bracket A criteria, that's it.
Is it A or SAS?
AAA. Why AAA? Because over here, just a minute, let me just check it. Okay. Just write theorem 6.3. Let me just check once a minute.
Okay, teacher.
Yeah, it is AAA. Why? See, over here, what is given? All the angles
Angles,
are
three
equal, right?
angles. Yes.
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 Robin, can you hear me?
Hello.
Yeah, Robin, can you hear me?
Yes.
Yeah. So this is AAA. Why? Because over here they have given you that all the things are equal, na? All the angles.
Yes.
So that's why this is A. Okay, in between you will use ASA, but this is A. Okay.
Okay, teacher. Yes, teacher, done. Yes, teacher, done. Yes, teacher, done. Yes, teacher, finished.
Okay. So we have 4.4, 6.4, which is very, very important. Okay. So I will explain you that's very Very, very important, but I don't want to miss it. We are running out of time as well. Okay. Okay, so let's just do the theorem 6.9 first. Okay, because 6.4 is very, very important. So what I will do, I will just explain you 6.9. Okay, and you will take the screenshot for this and you will complete it in your place. Okay.
Okay, teacher.
Okay. Today I don't know why my internet connection is unstable. My voice is breaking. Is it?
No, teacher.
Okay. Okay. Theorem 6.9. Okay. So in a triangle, if square of one side is equal to the sum of square of other sides, then the angle opposite to third side is a right angle. Okay. So this is what a triangle ABC is given, and AC square equals to AB square plus BC square. This is what is given. Okay. Now what you have to do, you have to prove that angle B is 90 degree. Okay. So construction, what you will do, you will draw PQR right angle to Q. Okay. Such that PB is equals to this PQ is equals to AB, and your QR is equals to your BC. Clear? Then what you have to prove? You have to prove that, let's just start with the proof. You know that you have to prove this angle is 90 degree. So in triangle PQR, you know, this is 90 degree. So by Pythagoras theorem, you know, hypotenuse and all that, right? So this
Yes, teacher.
PR is your hypotenuse equals to PQ plus QR
You are.
square. Okay. And since you know PQ is equals to AB and QR is equal to this, so you, instead of writing PQ, you can write AB. Yes, because you already said in when you were constructing, you said it, right? So this was your first equation. Now also it is given, this is already given, this equation, right? This is given. Yes.
Yes.
Yeah. So now what you will do from first and second, you can see that this PR is equals to AC now.
Yes.
Why? Because these two are same,
Ye-
right? So you got PR is equals to AC,
Yes.
PR square and AC square. So square and square got deducted. Then this, and then this triangle, these two triangles. In triangle this, over here what you can see, AC is equals to PR and AB is equals to PQ. Somewhere like this, these two triangles are congruent. Okay. So similarly, your angle B is equals to angle Q by CPCT.